Dear friends, welcome back to Data Analytics Talks. Hope all of you are doing great today. Thank you very much for all your support. Today's session is related to one of the topics related to data modeling. You know, we have had many sessions on data modeling, including the Irvine tool. And this is a special session requested by one of my viewers. And, the ask was to explain how to derive various normal forms, how to normalize a denormalized table. I can try my best to explain it using a real-time table. Then I will explain you how to derive 1NF, 2NF, 3NF, and 4NF. I will start with explaining some of the concepts like what is normalization, the benefits of normalization, then various aspects around this normalization and non-normalization. Then I will show you the workbook how to derive that. So this will be a simple session. I hope everybody can understand it. Let's try.
So welcome back. So I am showing you a list of policies. The record is showing the list of policies of some customers. If you closely look at this table, you will see that this is an unnormalized data set. It's a large data set with a single relation. There is no many relation, only single relation. I hope you agree that this is an unnormalized data set. I'm not sure if you know what will be the normalized tables. So if you go to a normalized, you can see there is a first normalization done from the data set, second normalization done, third normalization done, and fourth normalization done. Whenever you do normalization, you know, you are trying to create additional tables and try to make proper relation between them. So a large data set becomes multiple data sets and proper relationships is created. That is the gist of it. Okay, so I will explain it in detailed manner. So I am going to my deck and I will present to you the concepts, then the steps, then we will come back again to this workbook and I will show you how to normalize it. 1NF, 2NF, 3NF, 4NF, and so on. Okay, then finally you are good to go with the properly normalized tables from this large data sets of a single relation. Got it? Let's come back later. We will go and understand some theory. Okay. So, friends, my first question is what is the main problem of a non normalized table? In the Excel, I showed you a large database defined as a single relation. Okay. And the same thing I am showing here also. It's a large database defined as a single relation. What is it showing? It is showing a list of policies for our customers. Tom is a customer. He has a contact number. He has a policy number. And policy has different coverage. Then each coverage has different value. Right? And for which product he has taken the policy, that is a auto car model. And this car is from Maruti. Okay. So this is of course a large database defined as a single relation. Okay, there is no multiple tables to have multiple relation. Okay. So the main problem of non-normalized table is it may result in data duplication. That may result in data duplication. So she can in a way say that we are normalizing a table to avoid duplication, right? So looking at this large database table, you can easily identify there are different entities, right? Different, we can make different tables. For example, customer is a is one entity because customer has a name and customer has a contact number, and of course he has policies. Okay, but when you think of a table, you can think entity, you can think there is a customer entity. Second, when you think of another entity in this table is policy. Policy has a number, policy has a coverage. It has one coverage or multiple coverage, right? And each coverage you have to pay separate for first PIP. For that, you pay one amount. For BI, you pay another amount. For PD, you pay another amount. Okay. Then there is one more entity you can see product, for which product you are taking insurance, you are taking a policy. So there's a customer, there is a policy, and there is a there is a customer, there is a policy, and there is a vehicle. So this large database defined as a single relation can be split into multiple tables, right? That's what you need to understand first. Before you start your normalization, you will identify various things. Okay, let's continue. Then from an understanding point of view, what are the challenges of a non-normalized table? Okay, first of all, we understood that there is the non-normalized table is a large database and again defined as a single relation, and it can result in data duplication. So now we are going into detail and see what are those major challenges or issues that will be posed by non-normalized table. First one is making relation very large. Making relations very large. That is the first challenge. Second, it is not easy to maintain, update data as it would be involving searching many records in a relation. Probably you can think if I want to update something about a coverage, maybe about a value, when you have thousands of records here, like maybe millions of records, then it will be quite challenging to search and update records, right? Then there will be a lot of wastage and poor utilization of disk space and resources. That's another challenge. Then the likelihood of errors and inconsistencies increase as we have very large database with a single relationship. Okay, then what happens in a normalization process? Okay, what happens in a normalization process? So first of all, normalization is the process of organizing the data in the database. Okay, just remember normalization is the process of organizing the data in the database. Okay, maybe end of this session you will understand how we organize your data in the database. Then again, second one is normalization is used to minimize the redundancy from a relation or set of relations. So when you put everything in one basket, there will be a lot of redundancies. So in order to avoid the redundancy, normalization is used. Okay, then normalization divides the large table into smaller and links them using relationship. I was showing that we have a single non-normalized table will be split into 1, 2, 3, and 4 tables, right? So we are splitting one table into many table, and you will be connecting them with the relationship, either one to one relationship, many to many relationship, one to many relationship. So whatever in the context, you will be relating the tables with proper relations. So this is what happening when you are doing a normalization process. Of course, the normal form is used to reduce redundancy from the database table. Okay, so why do we need normalization? First, normalization helps to minimize data redundancy, greater overall database organization, data consistency within the database, then much more flexible data design, then enforce concept of relational integrity, then it avoids anomaly. There are mainly three types of anomalies, insertion, deletion, and updation. So for your information, so insertion anomaly refers to when one cannot insert a new tuple into a relationship due to lack of data. Then deletion anomaly means the delete anomaly refers to the situation where the deletion of data results in the unintended loss of some other important data. Then update anomaly means the update anomaly is when an update of a single data value requires multiple rows of data to be updated. For example, if I want to update the model of the car, then I will have to update all the records having that model in that table. So this is the update anomaly issue. So we remember insert anomaly, deletion anomaly, updation anomaly. Okay, can be resolved with a proper normalization. Of course. So when you do normalization, there are challenges. I don't know whether you expect challenges out of normalization. So we have been talking about challenges when data is not normalized, but there are also problems when tables are normalized. Okay, what are those ones? So the first challenge is that you cannot start building the database before knowing what the user needs. No, so because we have to have multiple tables, then proper relationship. So if you need to do that, you have to have good understanding about what the user needs in advance before you start designing your tables, okay, and database. Secondly, there should be a performance degrade when normalizing the relation to higher normal forms like 4NF, 5NF. So there will be so many joins, right? So of course, this is going to impact the performance, and it is not. It is affecting negatively the performance. That is, it will degrade the performance. Then it is very very time consuming and difficult to normalize relationship of a higher degree. Okay, so maybe you can ask some database modeling or database architect. So the challenges that they may face when they normalize in the higher degree. Then the careless decomposition may lead to bad database design, leading to serious problems. So these are some of the challenges posed by normalization. So you should remember there are problems when tables are not normalized. There are challenges when tables are normalized beyond 4NF, 5NF, etc. Okay. Then coming to the normalization rules, I am not sure whether you can simply understand it, but from a high level point of view, we have 1NF first normal form, 2NF second normal form, 3NF third normal form, DCNF. Again, it is another version of the 3NF. Then 4NF is fourth normal form, and 5NF is five normal form. So in first normal form, maybe I just go through definition and then maybe I will explain you when I am doing the normalization. A relation is in 1NF if it contains an atomic value. That means there is no grouped columns in that. Okay, I will show that in the next slide. What is that? Then second normal form is a relation will be in 2NF if it is in 1NF and all non-key attributes are fully functional dependent on the primary key. So that is 2NF. Then coming to 3NF, a relation will be in 3NF if it is in 2NF and no transition dependency exists. I'm sure this will be little difficult to understand, but I think and I'm sure and you will be able to understand it when we are doing the exercise. Then BCNF is a stronger definition of 3NF, is known as boy code normal form. Then 4NF, a relation will be in 4NF if it is in Boy's code's normal form and has no multi-value dependency. Then finally, again 5NF is a higher degree normalization, a relation in 5NF if it is in 4NF and does not contain any join dependency, joining should be lossless. That is a 5NF. So 1NF, 2NF, 3NF, BCNF, 4NF, and 5NF. Understand that what are we doing when we are normalizing 1NF to 2NF, 2NF to 3NF, 3NF to 4NF, 4NF to 5NF? In 1NF, you are eliminating repeating groups. We are eliminating repeating groups. In 2NF, you are eliminating partial functional dependency. In 3NF, we are eliminating transitive dependency. In 4NF, you are eliminating multi-values dependency. In 5NF, you are eliminating join dependency. So let's see how this looks like. So from here, please be a little careful. So here I have the non-normalized data set, right? So we have the list of policies for customer Tom. If I want to convert this non-normalized data set into 1NF, what is the condition? You should eliminate repeating groups. We should eliminate repeating groups. So what are the repeating groups here? Here you can find you have a coverage column, right? This coverage column is repeating, right? Because this is an option, this is an option, this is an option. Again, amount is 200, 100 and 150. They are repeated. Okay, they are repeated groups. So what is that we are doing in 1NF? We are going to eliminate these repeating group. Suppose we have 3 records here, right? So if I want to eliminate this repetition, I need to split these into 3, right? So one record for PIP, one record for BI, one record for PD. Of course, when I split these 3, automatically 200, 100 and 150 also becomes in different rows, right? So that's what is here. So Tom had 2 records in this case. So when I derived the 1NF, you can see Tom has 3 records. And this was the original record. So totally 4 records, right? And Alex, of course, he has only 1 record. There is no repeating groups. So totally how many? 1, 2, 3, 4, 5 records, right? So PIP, BI, PD become different rows and the values also become different rows. So when a normalized table is derived to a 1NF, then we are removing the repeated groups and adding additional rows. So this information remains good, right? P1, P100, P100, P100 and date remains same. What is not remaining same is the coverage and value. So again, this product is repeated, right? So this is how we do 1NF, first normal form. Got it? So coming to the second normal form. In this scenario, what are we going to do? We are going to eliminate partial functional dependency. Mhm. So what we will do, retain only the non-key attributes which are fully functional dependent on the primary key in the main table. So here you can see that all these attributes like the customer ID, that customer name, contact number, policy number, then they are basically fully dependent on the primary key. Okay, this customer ID is a primary key. This key, and this key all are, this is non-key attributes, right? Only the attributes are these, but non-key attributes are fully dependent on the customer. But coverage is not fully dependent on the customer, and amount is not fully dependent on the customer. Amount is basically dependent on the policy number, right? Policy coverage. Basically, this is basically dependent on policy, not the customer ID. So we will do one thing. We will actually take this partially dependent uh, attributes, non-key attributes, and put in another table. Okay, then we will create a primary key for that. So the coverage. So what happens? Then this coverage becomes dependent on this. This dependent on this ID. This PD dependent on this ID. Okay. Then we will add this primary key into the customer table. So what happens? Again, uh, this customer one with the policy P100 with coverage. These are all dependent on the customer, right? We will understand that this customer has a policy and this customer has a coverage, and this becomes a foreign key for the customer table, right? So we have removed all the partial functional dependency, and we split the main table into two tables. One is customer, one is the coverage, and we linked the customer with the primary key of the coverage as a foreign key. So that is where we get the 2NF. So what is the rule of 2NF? It is eliminate partial functional dependency. This is clear. Okay. You can simply search for what is partial functional dependency. Then try to understand that. Okay. In a table, what keys are fully dependent on the primary key? What non-keys are partially dependent on the primary key? So identify those partially dependent on the primary key columns and put it into a separate table. Then link back to the main table with the foreign key option. Okay, that's where we can derive 2NF. Then coming to 3NF. Okay, to understand 3NF, few things you need to understand. First, what is functional dependency? First thing you need to understand is functional dependency. Second is transitive dependency. So, what is a transitive dependency? A transitive dependency is when some indirect relationship causes functional dependency. So, I will explain you what is functional dependency. Say we have A, B, C. We have three attributes. Okay. So, A is related to B, A is related to B, and B is related to C. So, they are independent dependencies. So, that is called a functional dependency. And when A is related to C, in this case, it becomes a transitive dependency. I will explain you this with an example. Okay. So in the second normal form, what we did is we have separated the function dependency of the non-keys, and we created customer table and coverage table. Okay. So now, in this case, what we are into 3NF. So we need to remove the transitive dependency. So we were learning what is functional dependency, what is transitive dependency. So I will explain here. So we have coverage ID. This coverage ID is A, right? And we have product, that is basically B, and brand, basically C. So when A is related to B, that is a functional dependency. When B is related to C, that is another functional dependency. You understood? But when C is related to A or A is related to C, that is a transitive dependency. So in our case, we have a coverage. A coverage has a product. This product has the coverage, right? And you know, this product is related to brand. So in this table, when we keep all this together, there becomes a relation between A and C. There is a transitive relation. So we need to remove these transitive relation from here. So for that, what will we do? We need to split this table into two and create a new table for product. Okay. So we have the product. So this will be the K. Okay. So product Alto, brand Maruti. Right. Then Nexel, brand Tata. So we will associate this product K with the coverage. Right. So here we have A, we have B, we have no C here. So C is here. So what happened? We have functional dependency between A and B. We have functional dependency between B and C, but there is no functional dependency between A and C. So that's how we are removing the transitive dependency here. Do you understand? So what are we doing in 3NF? No transitive dependency for non-primary attributes. All columns should be identified by the key. So we eliminated transitive dependency and we got the 3NF. Okay. So in 3NF, a relation is in 3NF if it is in 2NF and all non-key attributes are functionally dependent on the primary key but not on the other non-key attributes. Okay. So to achieve 3NF, one must eliminate the transitive dependency. So the normalization of 2NF relation to 3NF involves the removal of transitive dependency. So did we do that? Yes, we have removed the transitive dependency and now we have got 1, 2, 3 tables. Okay, the first normal form we have 2 tables. First normal form we have removed the grouping. Second normal form we have removed the functional dependency of the non-keys, and the 3NF we have removed the transitive dependency. So far so good. Okay, so we have one more normalization. So we are into for enough. So important to understand the two of the highest level of database normalizations are fourth normal form, that is for enough, and fifth normal form, 5NF. So in for enough, we are handling the multi-value dependency. And in 5NF, we are handling a joint dependency, the joint dependency. So multi-value dependency and joint dependency. So as a rule, a table should be in for enough when it should meet Boy's code normal form and the table should not have any multi-valued dependency. Okay. Then you may ask, what is multi-value dependency? A table is said to have multi-value dependency if the following conditions are true. For a dependency A to B, if for a single value of A, multiple value of B exist, then the table may have multi-value dependency. Okay, coming to our table, you can see that we have a customer ID. Okay, this customer ID has a customer name, and we have contact number. Of course, the customer name will not change, but contact number can change, right? So when there is a relation A to B, what is requested is the if multiple value of B exists, then it is a multi-value. So maybe I can say I can get another contact number. So I can maintain multiple contact numbers there. So this B, when it is having multiple values, then this is meeting the multi-value dependency. And second, to have a table should have at least 3 columns for it to have multi-value dependency. Probably, yeah, we can say 1, 2, 3. Okay. That means it is also meeting that. Then the third one, for a relation ABC, if there is a multi-value dependency between A and B, and B and C should be independent of each other. Again, our table meets that requirements also. Okay, so it is having a multi-value dependency. Okay, so how are you removing that multi-value dependency? See, in that case, we can move this table into a separate table. Then you can see customer ID, then customer name, then we can see contact number. Right. So we will remove customer name, customer contact number from this table, and we will only maintain the customer ID. Look at this. So this is the new main table. So the main table has related to customer ID, and we don't maintain customer name or contact number the main table. Right? Any changes, any updates, all will happen this place. Right? So we have seen that how 3NF is converted into 4NF. I hope you got an idea about 4NF now. Please understand it. If you don't understand, basically you have to search about what is multi-valued, what is functional dependency, what's a transitive dependency, then try to map to your context. Okay, that will really help you solve these problems. And this can be solved only through exercise, to practice. If you're not able to do it at the first time, don't worry, keep trying. Yes, you will be able to achieve it. Then something we call it as a grain and cardinality. So grain and cardinality means it is showing like, okay, the relationship. Is it one to many? One to many is, see, a customer can have multiple policies and it can have policy start date differently. So that is always one too many. So in that case, one record for each customer that is in the grade that is in the customer table. But this relationship you can see here in this one record for each policy. Here one record for each policy. Then we have the policy number and coverage ID, one record for each policy and coverage combination. Then we have coverage ID, coverage amount, product. Then we have the product and brand. It's one to many relation. So one record for each product, one record for each product, one record for each customer ID, one record for each policy. This is a many to many relationship. So this is called grain and cardinality. These are some of the data modeling notations, like one to one optional on one side. You can see that, and maybe one many to one, then many to many, one to many. A policy contains at least one coverage. Then many to many, it looks like this. A driver drives various vehicles. So please go through these notations. It will help you when you start doing the modeling. So this is it. So to repeat again, one enough, a relation is in one enough if it contains an atomic value. It is in two enough. A relation will be in two enough if it is in one enough and all non-key attributes are fully functional dependent on the primary key. In three enough, a relation will be in three enough if it is in two enough and no transition dependency exists. That is transitive dependency. Then DCNF has stronger definition. 3NF is known as Boy's code normal form. Then 4NF, a relation should be in 4NF if it is in Boy's code normal form and has no multi-value dependency. Then 5NF, a relation 5NF if it is in 4NF and will contain any join dependency. Joining should be. Okay, I hope you understood the various normal forms. To do a recap, so we have started with a large database with a single relationship, and our goal was to get into a normalized form. And in first normalized form, we actually removed all the grouping. We added separate rows for all the comma separated values for the policy coverage and the amount. So this that is a one enough. Then two enough, we have removed the non-functional dependencies. So we created two separate tables, one for the customer, one for the coverage. So then the coverage is associated using the coverage ID. So this is a two enough. This functional dependency of the non-key is removed. Okay, in three enough, in the three enough, what happened? We had a transitive dependency, right? We have a transitive dependency for the product and brand and coverage. So we have taken out the product and we link the product key to the coverage. So with that, we came to 3NF and 4NF. We have the multi-value dependency. We created a new table for the customer. Then we associated the customer ID, policy number, and coverage. And we arrived at a 4NF. So we are not trying 5NF here. Hope you understand the various ways of doing the normalization and overall the concept of normalization. Done. Yes, let me know if you understood concept well.
Thank you very much for watching this video. Please stop your comments so that I can know how it has helped you. If you're exploring any topic in data analytics, data integration, data architecture, please let me know. If something I can help, I can always do that. If you like this channel, don't forget to like, share, and subscribe.